Friends, welcome to this channel Dr.ARM's Chemistry, and this is another lecture in continuation with the previous bonding in organometallic compounds. By this time we have seen number of various other factors in this case. Now we will see the next factor which affects the strength of bond, that is metal ligand bond, and this is using the pi bonding strength. So if we see the pi bonded cyclopentadienyls, and related species. So here we find that after discussion we will understand that how the pi bonding increases the strength, means what type of bonding is there, what is the effect on the structure of the molecule, etc. So this is a large class of pi bonded compounds which contain a group of unsaturated organic molecules as ligands. So this type of bonding means these compounds will show the presence of a group of organic molecules, that is ligands. So ligands are organic species which are containing the pi bonded, means unsaturation. So there is unsaturation here. The unsaturated organic species working as ligands are showing the structural effect as here. If we take the example of Zeis salt, for example, Zeis salt. And ferrocene. Another example is ferrocene. So Zeis salt is and ferrocene is CP2 cyclopentadienyl. So if we take this example, here we find that there are 3 platinum. So if we see this structure, there are 3 platinum chlorine bonds like this, and the 4th coordination is extended to this So this is the structure of Zeis salt, that is anion. So this is anion. Or we can write here, instead of this, we can also show here K, that is potassium salt. So here you will find that the 3 points of coordination are utilized by the 3 chloroligands, and 4th coordination is utilized by this unsaturated, that is double bond, carbon carbon double bond. So this platinum metal attaches to this C2H4 at this midpoint of this carbon carbon double bond. So there is a midpoint. So if we see the plane, square plane structure, so you will find that like this. So there is a square planar structure like this. So this is a square planar structure. Now if we see its atomic orbital diagram, then it shows that carbon sigma bond, and these are pi electron clouds like this. Now so these are the atomic orbitals available for pi bonding. Now here, if we see this platinum, it has the atomic orbitals like this. Now here, the interaction of this orbital of pi nature, this is pi star orbital, and this will interact with the electrons of this atomic orbital pi star will move into this orbital of platinum, and this will produce a sigma bond, because there is linear overlap, not axial overlap. But here you will find that the electrons of this platinum will move into this to give pi bond. Similarly, the overlap will be like this. So this is a part of this pi bond. So pi bond has two parts here. So in this way, sigma bond is produced from these parallel orbitals, that is of sigma orientation. So sigma bond is developed between this pi star orbital and this platinum orbital. So here we will find that the square planar structure is obtained. So you should get clear that the midpoint and these three chlorines and platinum are lying in the horizontal plane, that is square plane, and this carbon-carbon double bond is lying perpendicular to this square plane. So in this way we get this structure of this is salt. So similar to this carbonyls, the sigma donation is postulated as the from the ligands. So this time here we have discussed this thing, that is the field carbon-carbon pi orbital is sharing its electrons with the platinum, that is metal pi star orbitals. So carbon-carbon pi bond, this pi bond shares its electron pi orbital. So this we have pi orbital. So this is shared with the metal pi orbital of this is shared with metal pi star orbital, and this gives a sigma bond. Sigma bond. So in ferrocene molecule, the metal atom is sandwiched between the cyclopentadienyl ligands, which are lying parallel to each other. So if we consider the structure of ferrocene, it shows the rings of cyclopentadienyl lying parallel to each other. So if we see the structure, this is cyclopentadienyl and these are the hydrogens. So the center of this cyclopentadienyl is the C5, eta5. Eta5 structure means every carbon is bonded to this iron Fe. So this is hydrogen. So this is our ferrocene. Similarly, there is also cyclopentadienyl chromium. That is dibenzene chromium. Instead of cyclopentadienyl, we are taking here this is our dibenzene. Dibenzene. Chromium. Similarly, we can also have multi-layered structures up to six layers. For example, here we consider the tricyclopentadienyl nickel, which are triply sandwiched. this is tricyclopentadienyl. Means if you write this formula, it is Ni2CP3. Is triply sandwiched nickels. So we can have here in this way a multi-layered structure. So here there are 3 layers of CP cyclopentadienyl, but there are also some multi-layered complexes characterized, which are having 6 layers of the ligands, ring structures, unsaturated ligands. So these are called hexacyclopentadienyl sandwich. So here we can have the cyclopentadienyl, means 6 cyclopentadienyl or boron substituted cyclopentadienyl ligands. So we can have 6 CP. CP6 and boron 5. So cyclopentadienyl compounds are formed generally, which shows that most of the transition metals form the CP2M type of molecule. Most of the transition metals form CP2M type of species. So these are most of transition metals. Form such type of. Then first thought that and are all structurally characterized. Means all these structures compounds are structurally characterized, such as Titanocenes. That is Titanocenes, having required the coordination of neutral ligand such as carbon monoxide. So this requires neutral carbon monoxide ligand. Or we can also make use of PH3 hospenes to substitute to stabilize. So this will stabilize. Stabilize D2 metal center. D2 is the metals which are having D2 configuration, means there are 2 D electrons. D2 metal center. However, use of a substituted cyclopentadienyl ligand give, if we see the example, if we show the use of cyclopentadienyl, substituted cyclopentadienyl. Now if we take this example, we find that the C5Me4 means this is a part of the cyclopentadienyl, C5Me4 SiMe2. That should be butyl twice Ti. So this C5Me4 is a ligand which is bonded to this silicon, and this is also having 2 bonds with methyl groups and 1 bond with tertiary butyl. So here we will find that the cyclopentadienyl structure will show that here that 4 hydrogens are replaced by these 4 methyl groups. one will have this SiMe2 tertiary butyl structure, and this means two such highly substituted ligands will be bonded to this titanium, so which has a ferrocene like structure. This has a ferrocene like structure. Ferrocene like structure. And it is mononuclear, which are having the cyclopentadienyl rings. Means this titanium is bonded to the substituted C5H5, and H5s are replaced by these substituents. The related ions such as CP2Fe, CP2Fe plus, the related ions CP2Fe plus also readily formed, and the redox relationships between ions and a neutral species reflect the 18 electron system. So this is 18 electron system. 18 electron system. It is 18 electron rule. System is rule. It follows 18 electron rule. One interesting case is that CP2's CP star to Fe. So here the neutral compound is staggered. We have already shown the staggered structure of CP3. So staggered structure is seen here as CP3 and right. So these are staggered, means the carbon atoms of neighboring rings are not at the same direction, but these are different, means these are moving away as far as possible, so that the steric hindrance is minimized, and this gives stability to the structure. So like hydrogen analog, so that we have seen in the structure. So with this we will stop our discussion, and we have completed here this bonding part, one study of bonding in organometallic compounds, that is the metal ligand bond. So see you in the next point, in the next lecture. So till then, goodbye. See you next time. So if not subscribed to this channel, please do subscribe, and also please do not forget to press the like button. So thank you very much for watching this video.